Welcome to the session on design patterns with .NET. We'll start with listing the objectives in terms of what we plan to cover. We're going to look at what is a design pattern. We're going to look at why use design patterns. We're going to look at the history of patterns. We'll also look at describing a design pattern. We'll then get to the classification of various types of design patterns. And finally a demo with implementation of the pattern in C# with .NET. So what is a design pattern? I have a problem that occurs over and over again in my software development scenario, and I have a solution to that problem that is a best fit to get over the roadblock that I'm facing. And the solution can be used and reused across various domains and can be reused a million times over. And that is something I would call a design pattern. So basically an innovative design decision that I could reuse across various modules in my project or across various projects in my organization. So the concept of a pattern is that I should be able to reuse it. Another benefit of using a pattern is that it's a tried and tested mechanism for getting over common roadblocks or problems that we face in our software development cycle. So instead of me innovating and thinking of the best class collaboration that I could have, I can rather reuse what's already recreated, and using the pre-created content ensures that I get over commonly made mistakes and that I really don't have to think of challenges that I would face if I use the common set of class collaborations that exist. Finally, it allows me to establish common terminology between my team members and my customers. So when I'm talking to somebody else in my team, I really don't have to talk in terms of, okay, there's a base class and a child class, etc. I just need to mention the design pattern name. It could be an adapter pattern, observer pattern, etc. And that would send home the message that, okay, this is the class collaboration diagram that I'm actually talking about, and this is how I should position my classes and make them communicate with each other. So how did design patterns originate? It had nothing to do with the IT industry per se, but it came from Christopher Alexander, who actually created patterns for overcoming common design issues that were faced in the construction industry. And he listed these solutions in his book titled A Pattern Language. One of the common solutions that he talks about is if you have an office complex that you're constructing, and if you have the boundary wall probably 5 to 10 feet away from the main facade of the entrance of the building, people would kind of get disinterested or exhausted, or probably there would be a lot of heat, sunshine that they need to walk across through and then get to the main gate of the building complex, and hence setting up a lawn with some greenery to absorb the heat and make it easier on the eyes for the person to walk through the main facade of the building would help. And that's a common pattern he talks about. Rather than investing cost in setting up a shade and putting up some kind of permanent structure all the way from the boundary wall entrance to the main building entrance. So common design issue solved with a simple solution. And that's where the IT industry picked this up, and you had 4 developers, Eric, Richard, Ralph and John, popularly known today as the Gang of 4, who came out with their adoption of how commonly faced problems could be solved with innovative class collaborations and object compositions, which they termed as design patterns, and documented that in their book titled Design Patterns, Elements of Reusable Object-Oriented Software. Now, you could yourself create a design pattern that you would want to use across various modules in your project. And how did you identify if your solution is a design pattern? First, look if it's a generic solution. Can it be applied across multiple domains? Look if it's reusable. Can it be reused across various scenarios? And is it context specific? Does it solve a particular business problem that you face when creating and developing software? If yes, then your solution classifies to be, or it justifies itself in terms of being called as a design pattern. You should also demonstrate the consequences that using your pattern would have, so that developers would be aware that if we use this class composition and collaboration, these are the issues that could typically come up. Now, there are various types of design patterns. So design patterns document what you should be doing, best practices. You have GOF design patterns like the one we've spoken about. You have non-GOF design patterns, which are classified as .NET patterns or J2E patterns, Java specific patterns. So when I choose a design pattern, how do I identify? There are 23 design patterns. How do I identify that this is the right pattern I want to use for this specific problem that I'm facing? To do that, let's understand how are design patterns further classified. You have a set of creational patterns that talk about the process of object creation. So if you're talking about isolating the object of process creation from the client or from the client component so that your solution is flexible to change, I would be using the creational pattern. I would use structural patterns when I'm talking about composing class objects together so I have better reusability. I'll be talking about behavioral patterns when I characterize the way in which one class communicates with the other. So these are the three areas I need to focus on. If I'm facing a problem when I'm instantiating my class and I need loose coupling out there, I would use a creational pattern. If I'm talking about reusing existing class objects to create something different, I would use a structural pattern. And if I talk about communication or collaboration that is happening across various class objects, I would be using a behavioral pattern. So under creational, some of the design patterns that we have are listed here: abstract factory, factory method, singleton. As part of structural, we've got adapter, bridge, and facade, which are structural patterns, and then behavioral patterns like iterator, observer, state, etc. Further to this, we could actually classify a design pattern on a second criteria called scope, which means that I could have a class level pattern. A class level pattern is more of a design time or a compile time static decision. I use inheritance, which is again not a dynamic way of composing classes together, but it's more of a static time decision. And hence these are called class patterns because you modify classes or class structures and use inheritance to create coupling between classes, and that's how you innovatively set up your class collaborations. So when I deal with relationships between classes using inheritance, it's a static fixed compile time decision that I take, and those kind of patterns that talk about using inheritance are class patterns. Object patterns talk about composing existing class objects together and a little more dynamic in nature because they allow switching between various class objects on the fly and are more hot pluggable, if you were to say so, in nature. To implement an object pattern, I would need to use composition, composing various class objects together, or delegation, calling one class method from another and delegating the work to that particular class, saying that this is what you know a specific class should be doing. So if you look at the broad picture here, you would see we have a very few design patterns classified under class scope, which means that these are static compile time decisions I would take when I'm composing my class structures, and most of them are at object scope, which means it's more about dynamically switching between object types, composing new objects, and reusing as much code as possible, and hence achieving a flexible, maintainable application. The first pattern that we're going to talk about today is called the singleton design pattern. And the intent is that a class should have only one instance of itself created, and I should provide a global point of access to call and access the class only via its single instance or single object that has been created. Now, why do we need something like this? Why is it important for a class to have exactly one instance? Okay, let's take an example. If I have multiple printers in my office, I would have only one print server managing all the print requests that are coming in to various printers that are set up. Okay, I would not need one print server for every printer that I have installed, because if I did that, I wouldn't have effective management of the print spooler. So just one print spooler service should get the job done in terms of delegating which is the right printer that this print message should go to. And this is one reason why I would need a singleton pattern where only one instance of the prints class or the print server or the print spooler should be able to manage n number of printers. Let's take another example. When a developer creates classes, a class is supposed to be slotted into either one of these categories. So you create a class that has business logic in it and it's classified as an entity type. I could create a class as a boundary type which sits at the periphery of my system. Boundary classes are classes which talk to external subsystems, go outside my class and communicate with external components like a web service or information coming from a barcode scanner, etc. I have data store type classes. These category of classes talk to data stores and communicate with and deal with persisting information into the database. And then I have a controller class, which is more like a conductor of an orchestra, which doesn't do anything himself, but actually conducts the entire flow of music by coordinating and telling each musician what he's supposed to do in an orchestra. So a controller would delegate work to the entity boundary and data store class to ensure that the use case is flowing now. So for every use case, typically I would have one controller created, which would run the entire workflow for that particular use case. And I should ensure that I'm not adding references of entity types into boundary classes and boundary class types into data stores. All these references are routed only to the controller. So it's only the controller who plays the role of super user, and this ensures that your application is flexible to change so that you don't go and modify all the various class types. If you just have a change to the UI, probably I just touch the boundary class because that's the one dealing with the external interface. If I just want to modify persisting data to the database, I just touch the data store class. And of course, if I have a change to the business logic, it's only the entity class that needs to be changed. Let's take an example of a library management system. If I wanted to develop something like this, we'll take a single use case that we are considering here in terms of our discussion, where a new book needs to be added to the library management system. So I'm going to have a main form, which is the boundary class, and the main form is what the librarian will first open up when they start accessing our software. The main form immediately calls up the book title controller. The book title controller calls a method on the book title form and brings it up, saying that this is the screen where data entry should happen. The librarian now starts entering data into the data entry screen, and all of that data is sent back to the controller class. The controller then sends that data to the book title class and creates a new object of a book title type. The book title is an entity class. The book title object is sent back to the controller, and the controller now calls a method on the data store class, telling it that please go and persist this new book title object into the database. So if you look here, it is the controller running the show, and hence for this use case of adding a new book to the system, I would need only one instance of the controller class to be created. And hence a classic example of why I would need the singleton design pattern. I would need only one controller. You don't see two conductors conducting an orchestra. They would be complete chaos in that case. So one controller per use case is the thumb rule, and I would need the singleton pattern to ensure that I have only one instance of the controller being instantiated. Another example, if I talk about distributed computing, let's assume I have a client, and the client is talking and calling a class object that's hosted on a remote server, probably using Windows Communication Foundation in .NET Framework. Now, I could control how many objects I actually want created of the service, because that will really control the speed and the scale up of the number of clients connecting to me. So I would have configured my service as singleton to say that only one object is going to be created for my service, and this single object is going to service n number of clients that are going to connect to this particular server. Another example of why singleton would be used to control the number of object instances created at the server side. So I could have less amount of RAM, but I could still scale up to n number of users innovatively connecting to my service, calling just one object, a method on that object to probably execute some business logic that I have written at the server end. Let's take up a task in terms of the demo that we will do with C# and try and implement the singleton pattern. I have an account class here with account ID, balance, and holder name, and I have a single function that will return unique account IDs to me. Now, if you look at the implementation here, the get account ID function is tightly bound to the account class, so there's no reusability. If I want the same block of code to give me unique customer IDs, I wouldn't be able to use it because of the tight coupling of this block of code with the account class. So, in order to make the generation of the unique account ID reusable, I'm going to push that into a separate class called ID generator. Now, the sole purpose of this class is to generate random and unique IDs, and I could then use them probably for account IDs and assign them to an account ID in an account class, or probably I could have assigned it to a customer ID in a customer class. And I do not need multiple instances of my account ID generator. I would just need a singleton instance created of the ID generator, and any class that wants a new ID simply calls a next count function that's set up in my ID generator to generate the next ID, unique ID, and retrieve it. So to do that, what are the steps I'll have to perform? I'll have to make the constructor private of my ID generator so that nobody can directly create an object of this class. And I'll add a static method to the class, which will be my single access point of ensuring that a single object gets created of this particular class. So let's get to the demo and see how this is done. I'm opening up Visual Studio. I'll create a new project. It's going to be a class library project, and I'm going to call it bank library. I'll rename the class to account. I'll create an account ID attribute inside the class, account holder name, and balance. Let me refactor and create properties for the three attributes that we have. I'll also add one for the balance. So properties created. So these three attributes can be accessed publicly outside the class. Let's add a new class to our application, and I'm going to call this class ID generator. The sole purpose of this class is to generate unique IDs that I can use inside my account class. So every time I have a new account object created, I should have a unique ID generated by this class and assigned to my account ID. So I'll create a variable called count, which will keep track of the number of IDs created. I'll create a static object of this particular class within itself so that I can control the number of instances that are getting generated for the class. I'll have to mark the constructor as private so that I do not allow anyone to say equal to new ID generator and create an object of this class. I'll now need a static method. Just add it outside the function. So the sole purpose of the static method would be to control the number of instances that are getting created here, and we should have only a single instance of this class that gets created. So I'll check that if the account ID generator object is not yet initialized and is equal to null, in that case I'll go and initialize it by saying object equal to new ID generator, and then I'll return that object to any client component that requires it. Else I'll just return a reference to the same object that's already initialized. So if the object is already initialized, I return a reference to it, else I create a new object and return that. So at any given point of time, I would ensure that users of my class create only one single object of it. I have a next count function that will increment the count. Just build the application to check if things are fine. I'll now get into the account class and I'll set up my constructor. Now this is where I'm going to say ID generator and the object of that class, and since I have a static method defined, I can simply call it with the name of the class, so I don't need to actually say equal to new account ID generator and generate a new object. And that's where now I simply say object dot next count. So if you observe here, the moment I create an object of ID generator, I'm not manually creating it by using the new keyword, but I'm ensuring that the class itself generates one unique instance or object of itself and returns it to me. And it's always the same instance that I will be using to generate the next count. We'll also add a parameterized constructor in case somebody passes the holder name and the balance. In that case, we simply assign it to the class attributes. I'll also assign balance. And now I need to ensure that if somebody is calling the parameterized constructor of the account class, it also goes and forces a call to the default constructor and the ID gets assigned to the next incremented unique value. And for that, I'll simply ensure that via the this keyword, a call always happens to the default constructor as well. And that's how the account ID will get auto populated. So once this is done, I'll create a new project, a console application. I'm going to call it bank client. I'll set it as my startup project. I'll add a reference to the bank library. Move to the program.cs entry point. This is where I'm going to create, let me add the using statement on the top. So using bank library. I'm going to create 3 account objects. So account object equal to new account, an array of 3 account objects, initialize a for loop to run through the 3 account objects and initialize each and every one of them. And when I do this, I would expect the default constructors of the account class to fire, within which we've actually generated a call to the ID generator, and we would expect unique IDs to be generated. And I'm just going to output them. So let's try an outputting object I dot account ID. So when I execute this, Mr. Semicolon, control F5 to execute, and you would see I have 3 unique random account IDs getting generated for the 3 account objects that I've created. And the key here, the key takeaway of the design pattern that we've learned, which is singleton, is the creation of the static method to ensure that this class generates only one